Today I'm going to show you how to do a routine urinalysis. We start with 3 mLs, which is used for interpreting microscopic sediments. If you get less than 3 mLs, you should record it on your report form that you had less. It's important to analyze your urine as soon as possible after collection. That's not always possible, so you'll need to refrigerate it. If you do refrigerate your urine, you need to let it warm for 30 minutes before testing. This is so that your strips are meant to react at room temperature, and it may help redissolve some particles that have formed because of refrigeration. And be aware that crystals may form in a urine that has been refrigerated. So to start a urinalysis, you want to just gently mix your urine. You don't want to shake it. You want to take one of your urine strips. These strips containers has a desiccant in the lid, which keeps your strips dry. So as soon as you remove a strip, you want to put this lid back on. So again, just tip your urine forward, let it run up the length of the strip, and tilt it back. It's a quick 1-second dip. Then you want to let your strip sit for 60 seconds, and after 60 seconds you can read all of your results. When you're doing your urinalysis, you want to note your color and clarity and record it on your submission form. So your color, you call it whatever you see. So this one would be slight cloudy, dark yellow. There are various colors, and for turbidity, you would call it, you do your turbidity by holding it to the light or over paper with some printing on it. Clear, you don't see any kind of particles in it. Slight cloudy, you see just a few particles. Cloudy, quite a few particles in there, but you'll still be able to make out printing. Turbidity, when it's turbid, you do not see printing. You won't be able to make out any printing, and that's the difference between your cloudy and your turbid sample. This is basically your normal urine color. It's a yellow color, and that is what majority of your urines are going to be. You can also get a very pale colored dilute sample. You can hardly see any color to it at all. And then you can have your amber colored urines, which is usually bilirubin in your urine, and it's just a kind of a brown yellow color. And you can also have kind of a greenish color. And there's various colors you can see. You can just call whatever you see. And this one here looks like it has some hemoglobin in it as well. It's kind of a red color. So we use a ChemStrip 10A, which is designed for an automatic strip reader. So the very last square that's on your strip is going to correspond to the blank square that's at the bottom of this strip. So you hold your strip with the handle at the top by the lid, and that last square corresponds to the blanking square at the bottom. To read your strip, you start with the specific gravity, which we don't read because it isn't accurate in animals on reading on the strip. Then we do the pH, and we report it as intervals 0.5. Leukocytes is not considered significant in veterinary medicine, so we don't report that. And be aware that in cats, they excrete an esterase, so this is always going to be positive in cats. Nitrites, again, is not considered important in veterinary medicine, so we don't report it. Protein, we report as negative trace and up to 3+. Glucose is the next square, and you can report that as negative and up to 3+ as well. For ketones, what you're looking for is a purple color, and it is reported up to 3+. And sometimes you'll see a brown color, and that is interference. Urobilinogen is not considered significant in veterinary medicine, so we don't report that as well. So the 3 things we don't report are leukocytes, nitrites, and urobilinogen. Bilirubin is reported as negative up to 3+. For blood, you're going to have 1 square on your strip and 2 squares on your strip container. The speckled one is the intact red cells. The solid one is the hemoglobin. We don't differentiate it, we just report it up to 3+ and greater than 3+ if blood is actually visible in your urine. So again, 2 squares on your container correspond to 1 square on your strip. So that's your strip. How to read it, you read all your reactions within 120 seconds. After you're done your strip and your appearances, you want to centrifuge your urine at 1500 RPMs for 5 minutes. Today we have one that we've already centrifuged for you. So you can actually see there's some sediment at the very bottom of this tube. Once you have your urine centrifuged, you want to pour off the supernatant. And this is done in just one quick tilt forward and tilt back. The tubes are shaped to leave the correct amount at the bottom for your sediment. The supernatant, the part that you've poured off, is what you want to use for your refractometer reading, and of the specific gravity. All refractometers are made slightly different. So you read the scale that is a 1.0, and just that, whatever your refractometer you're using, that's what scale you will see. So you just flood your urine onto the scale. Make sure it covers the full length of the scale in there. And just look inside and get your specific gravity reading. So today ours is 1.050. So now that you have your sediment, you want to make a slide. And we use both stained and unstained sediment for our analysis. The unstained is where we do all of our counting. As the stained part, when you're looking at that, it actually dilutes your sediment, and it adds artifact that can easily be mistaken for bacteria. So you always want to do all of your counting off of the unstained urine and just go back to the stained urine if you have, you need some help identifying something. So what you do is you put 2 drops in 2 spots on one slide. And to one of those drops, you add a drop of SETI stain. We aliquot our SETI stain into little containers. That way there's less chance of contamination, and we don't contaminate the whole bottle if we do have bacterial growth in there. So you want to cover set both of your drops, and the drop that has the SETI stain in, you mix the stain and the sediment together with the edge of the cover slip it, and you're ready to go to the microscope. Don't be worried if you get bubbles in your urine. Bubbles are very good because you can actually focus on the bubble if you have a clear urine and know that you're on the right plane.